Hi folks, welcome to lecture 19, and in this lecture we'll be taking a look at function manipulation. So first of all, say if I gave you this very straightforward problem. Go into a shop with €2, you come out with 3 apples and 20 cents change. So how much was each apple? So here's there's our outcome and there's our input. So we have an output and an input. So I think most people would, after a few minutes thought, come up with 60 cents an apple. And if you're getting 60 cents, guys, you're able to manipulate functions. So that's what I'm trying to develop here. So we quickly take a look. So first of all, what you would have done was you would have taken 20 cents from both sides. That now leaves us, well, we'd figure 3 apples must have cost €1.80. Then divide both sides by 3 and we figure 1 apple is 60 cents. If we just replace the diagrams with numbers, we can start to see. Now first of all here, we're actually going to try and isolate A. That's what we're aiming to do. There's 2 things acting. There's this plus 20 and then there's this 3 multiplied by. And the order, guys, this is what I'm trying to emphasize in this lecture, is we didn't try and take away the 3 first of all. Our first step was to get rid of the 20. Then we had 3A was 180 cents. And then we divided by 3. So the order in which we do things is paramount. And then which operations we choose is also very important. These ones in red are our inverse operations. Here we have 3 by A. To kill multiplied by, we use divide. So that, guys, is kind of function manipulation in a nutshell. So we're looking for a systematic order in how we arrange and rearrange functions. And it's really the operations. We're not so interested in the 3 and the 20. It's much more, how is the 3 joined on to A? Is it by multiplication or is it by minus or plus? That's what determines what we do. So any variable in a function can be isolated. And this kind of procedure can be called manipulate the function, isolate x in the function, make x the subject. There's lots of different ways of saying it. So you'll probably come across most of them in this module anyway. So your method, first of all, identify the subject. That's what you're asked to isolate. I have him colored blue. Then identify what we need to move. And we're going to use the inverse operators to move these unwanted bits away. So it's kind of best explained by example, but just to remind us, if we need to kill a plus, we use a minus and vice versa. If we need to kill a multiplied, we use divide, or undo, I should use is less violent. If we need to undo squared, we use square root, and vice versa. And remember the new one this year, if you need to undo a base of 10, you use a log with a base of 10 to undo it, and vice versa. So we're going to look at each of these in turn, just one example just to show you the process, and then we'll move on to more complex formulas, fairly quick functions as well. Functions and formulas, guys, are fairly interchangeable in this lecture. Like, I'm trying to move towards the word functions because that'll be the basis of semester 2. And really they are functions. They're both, but I'm trying to keep consistent with using the one word, functions. So here we have a function which relates Kelvin and Celsius. It's very important to understand here, guys, Kelvin is the input. If I know Kelvin, then I can calculate Celsius. So Celsius will be the output of this process. So we'll start to define that now. This becomes very important in next semester. So we want to arrange the function so k is on its own. We want to make K the subject. So first of all, we identify the subject. And now in red, guys, I've identified, well, this is what I want to remove. It's not so much the 273 I'm concerned about. It's much more, how is 273 joined to K? It's joined with a plus. What's the inverse of plus? Is minus. So I'm going to subtract 273.15 from both sides. So this is it written out in full, guys. You don't need to do this, but this is just showing you the process. A lot of people say bring it over and change the sign. That's what it looks like happened. But really what happened was we applied the inverse of plus 273 to both sides. Now on the right hand side, they cancel each other out and they simply disappear. And we get here. So in normal maths, guys, it's perfectly okay just to go without that middle line. So now, guys, we've got K on its own. Finally, always write your subject on the left. So I know it's a little bit elaborate, guys, for but I'm really trying to set us up with this idea of using the inverse operator to remove what we don't want. Now, with the new function, if we know Celsius, we can now calculate degrees Kelvin. Multiplying and dividing. So here's a function that relates power, voltage and current in relation to power. So if we know the voltage and the current, we can calculate the power drawn by whatever we're looking at. But say we only know the current and we know the power and we want to calculate the voltage. We want an output of voltage. In other words, we want V on its own. So our subject is V, we've him coloured in blue, and now I want to get rid of this multiplied by I. So I want to get rid of the I, but what's crucial, how is I joined on? The inverse of multiplied is divide, so we divide both sides by I. On the right hand side, they cancel each other out and we get this. And again, guys, normally you just go from that step to that step. Now we have our subject on its own, that's what we want. Finally, we write the subject on the left. So always write the subject on the left, guys. That's the normal format for writing functions. Now, if we know the power drawn and the current, then we can calculate the voltage. Here's a motor. And again, guys, what I'm trying to say here is none of you probably will never encounter motor torque in a problem again, but I'm trying to show you that you don't really need to understand the system in order to be able to do the maths. I'm sure you remember your Greek letters. I'm sure you're screaming at the thing going, oh, that's tau. And this here is omega, as one of my students called it once, was W, which I've always liked. But tau, guys, is the torque and omega is the rotational speed. So if we know the power drawn and the rotational speed, we can calculate the torque developed by the motor. Torque is what kind of wins races. Power is what sells the car, the horsepower, but its torque is what wins races. So rearrange the function, so P is on its own. So we want to get rid of this thing. Well, first of all, we say, well, we'll write the function and identify my subject in blue. And I want to get rid of this omega. But what I'm really asking is, how is omega joined to P? It's joined by division. So to kill division, I use multiply. So I'm going to multiply both sides by omega. This is what it looks like. On the right hand side, the omegas cancel. That's what we're designed, that's effectively what we're wanting to happen. We now have P on its own, and finally we write P on the left, and that's equal to tau by omega. So now if we know the rotational speed and the torque, we can calculate the power developed by the motor. Or the power developed. Pythagoras, most of you will be familiar with the function. And in this case I want to get C on its own. We'll discuss Pythagoras in more detail next semester. So here's my function, here's my subject in blue. I want to get rid of squared. What's the inverse of squared? It's square root. So now guys, the square root isn't finicky. It doesn't go in and square root each bit separately like that. It's not a kind of finesse tool like that. Everything on both sides gets square rooted. That's the way it works. So we're doing it to both sides, so you simply put brackets around both sides and do it to the whole lot. On the left hand side, square and square root, we're kind of familiar with this. The square root of x squared is just x, and that's what we wanted to happen. And finally, our subject is on the left, so we don't need to change anything. So this now will tell us, if we know A and B, we can calculate the length of the hypotenuse, the longest side, C. And you could use this if you were doing any kind of roofing or anything over the holidays. This is a very useful formula. Cubed roots, we just take a quick look at a cube root. I kind of went for the simplest possible cubic function, which is for a cube. The volume of a cube is given by a cubed, a by a by a. And we want to get a on its own. So we want to kill to the power of 3. One way is by using the reciprocal power on both sides, but we're more familiar with this is the cube root. So that's what we do. We get the cube root of both sides. So here's my subject in blue. Here's what I want to get rid of. Get the cube root of both sides. On the right hand side, the cube and the cube root cancel each other out. I now have my subject on its own, A, and finally I always write my subject on the left. So final one then guys, just looking at the formula for pH. This is a nice lead in to the next section where things get a little bit more detailed. Here guys we have formula pH is minus the log of H plus ions, and it's difficult to make any kind of head or tail of it. Remember that is log to the base 10 though, even though it's not written in. And first thing guys, we want to get the hydrogen ion concentration on its own. So we want to get that bit H plus in brackets on its own. So there's two things. We have to get rid of the minus and we have to get rid of the log. You always work from the outside in, so we need to get rid of the minus first and then get rid of the log. So that order guys is critical. So to get rid of the minus, really what we do, most people are familiar with just changing the sign on both sides, but really what we're doing guys is multiplying every term by -1. It's a bit more formal, but it's more rigorous. So if there's 3 or 4 things, if there's 3 or 4 terms in the expression, everything would get multiplied by -1 and everything would change its sign. So now we've got rid of the minus. We can still see our subject in blue. The next thing we want to get rid of is the log. And remember, this is log to the base 10. So the inverse of log is 10 to the power of. And this looks weird guys, we raise both sides as a power on 10. And it looks a little bit odd guys, but we're doing science maths and it just does tend to look a bit odd. Now on the right hand side, they kill each other off. Remember, that is log to the base 10. So they kill each other off. And now we've taken away the base, guys. The hydrogen ion concentration just drops down. It's no longer a power. And finally, we write the hydrogen ion concentration on the left. So that one's a little bit trickier, guys, but you can see it's the exact same principle. We want to get rid of the log, so we use the inverse operator to do that. So now, first question for you guys to try. Just have a go at each of these. Don't forget to pause the video. These are all just simple one-step functions, so hopefully it shouldn't take you too long to work your way through each of them. Beware of your subscripts and stuff like that when you're writing out your answer. Now we'll just take a look at more complex functions, guys. It's the exact same process, but like the previous example with the pH and the log, we need to be careful with the order in which we do things. So many functions have several operations and variables, several operations acting on the variable that we're interested in, our subject. So we use the same techniques from the previous slides, but now we just need to be a little bit more ordered in what we do. So identify the subject, and then in red the variables and operations that we want to get rid of. We start at the furthest away one. The variable furthest away, or the number furthest away from our subject, is what we move first. This is the first to go. Work from the outside in towards the subject. Use inverse operators just like we saw in the previous slides. So depending on what operation we're trying to get rid of, we use its inverse. Do the same thing to both sides, and literally put brackets around both sides. And then if we're squaring it, square both sides, etc. That's very important, guys. You don't kind of get to be, you don't get to choose which bits get affected. The whole lot gets affected by whatever you're doing. And we'll keep doing this until the subject is on its own on one side. So again, it's very hard to put words on stuff. Once you watch the process, it gets a little bit easier. So here we have a linear motion function. This is one of Newton's functions. This is what each variable means. I won't get into that too much. That's physics. We don't need to know the system we're looking at to be able to do the maths. So we're asked to make t the subject. So here t is on its own. Or not so much on its own, that's what we want to achieve. But here we have t identified in blue. There's two things, guys, we need to get rid of, the u and the a. And the question you ask is, well, which is furthest away? The u is furthest away. So the u, guys, is going to be the first thing I'm going to try and get rid of. And what's not written there is, though, but it's actually just plus u plus at. So I want to get rid of plus u. What's the inverse of plus u? That's what I want to get rid of. It's minus u. So now I subtract u from both sides. So I'm not writing in that intermediate step anymore where the minus u appears in red on both sides. So I've subtracted u from the right hand side, and when I subtract u, from the left hand side, and when I subtract u from the right hand side, they cancel out, which is what I wanted. Now we can see my subject is still in blue, and what I want to get rid of next is in red, which is a. A is joined on by multiplication. So to get rid of a, I need to divide both sides by a. Now t is on its own, which is what I want. Finally, always write the subject on the left, and this is my new function. So the order, guys, is you can't get rid of a. First of all, if you try to get rid of a, say divide by a, you have to do it to all three terms. So if you're doing something, you have to do it to both sides. So that's why we get rid of u first, and then we divide by a. The maths is a lot easier. Looking at another linear motion function, again, it's the same system, but it's just a different version of the functions. We've now got the variable s involved, distance. And in this case, we're asked to actually isolate x. So here's our function with our subject in blue. And we can see now, guys, again, there's two things affecting it, u squared and 2a. But the process is the same as the previous slide. We get rid of the u squared first because that's furthest away. We subtract u squared from both sides. Then we want to get rid of the 2a. You could do it divide by 2, guys, and then divide by a, but they're both joined on by multiplication. You can really just put brackets around them. And divide both sides by 2a. Now we've got our subject s on its own. In terms, we could say express s in terms of the other variables. That's another way. I knew there was another way I hadn't discussed. Always write our subject on the left, and there we have s is equal to v squared minus u squared all over 2a. So it's a very important skill, guys, as a scientist, to be able to manipulate a function to express any variable we want in terms of all the other variables. So here's a question for you guys to try. This is another linear motion problem. And we want to rearrange the formula, the function, so that v is our subject. So we need to get rid of a 2, we need to get rid of a u, and we need to get rid of a t. And if you do it in that order, you should be okay. No, actually, 2 first. Sorry, what am I doing? Get rid of the t first, then get rid of the 2, and then get rid of the u. Sorry about that, guys. So 1, 2, 3. That's your order. I better not mess around anymore, yeah. So I'll push on. Fundamental frequency of a stretched guitar string, or any string. This is, engineers get into this a lot because resonance is a very important thing when you're building anything, that you know all about its natural frequencies. And here again, guys, it's a function. We don't really need to know everything that's in it. Rearrange the function to make t the subject. So we'll just do this on the next slide. Isolate t, that's what we're looking for. Here's t. And in red, guys, I have what's furthest away from t. 1 over 2l. So that's what that is. It looks, the 1 and the l look very similar. It's just a font. So this is really just like 1 over 2l by the square root of t over mu. So we want to get rid of this, guys. So it's joined on by multiplication. So we're going to divide both sides by 1 over 2l. But to make our life easy, guys, rather than writing, divided by 1 over 2l, and remember we'd flip and multiply. So it actually is easier to do that flip and multiply. We're dividing by a fraction. So it makes more sense to actually just flip it and multiply it from the start. So we're actually going to multiply both sides by 2l. So the 2l appears on the left, and the 1 over 2l gets cancelled because we've now got 1 over 2l on the left and we've multiplied it by 2l, and they cancel each other out, and that's what we wanted to happen. Now on the right hand side we still have t over mu, and the square root, guys, is we can't do anything with that mu until we get rid of the square root. So inverse of square root, we know, is squared, so we're going to square both sides. And again, guys, just draw brackets around both sides, square them. That'll kill, those two will cancel. and we get this. And notice how on the left hand side I just put brackets around everything and squared it. Finally then guys, now I've only got the mu, that's what I want to get rid of the bottom. It's joined on by division, so to get rid of it I multiply both sides by mu, and I get this. Now I'm going to write my subject on the left. As always, I'm going to tidy things up a little bit. Just square out the 2, we get 4. Always write your numbers at the front guys. Then we have the constants, and then we have our variables. So now guys, there's just a couple of questions for you guys to try. And again lads, I'm not pretending this is easy. I would expect you to struggle with these because generations of students before you have struggled. So this isn't easy, but I hope you do realize its importance in kind of a scientist's mathematical toolbox. So here we have a period of a pendulum is given by this function. So the period guys is the length of time it takes to complete a cycle. L guys is the length of the pendulum. And it's a whole thing with pendulums is that it actually doesn't matter how big the ball is. The mass of the ball doesn't matter. The thing that determines the period is the length of the string or whatever we're looking at. So now you're asked to make L the subject of the function. Sorry, that all disappeared a bit quick. So again, just pause the video, have a wee go at it. Next question we're going to take a look at is decibels. So next semester we're going to examine decibels in a lot more detail. But it's a log function. It's a function that depends on logs. And this is the formula here. dB is 20 times the log to the base 10 of p over p0. p0 is just a reference value. It's the lowest value a human ear can hear. But like I said, we'll discuss it more next semester. So rearrange the formula or the function to make p the subject. And now one more question. This is isostasy. So what isostasy guys is really the study of is how dense we can work out lots of things from an iceberg. If we can measure the height above water that's showing, and we know the density of ice, rho O, density of the object, I'll just write it there, rho O, and we know the density of the fluid, rho F, then guys we can calculate the total height of the iceberg. So it's one of the properties that with a couple of simple measurements, the height above sea level, densities, 2 density figures guys, we can tell an awful lot. So the function looks like this. And in this case, we're asked to isolate the density of the object. Now you can just give, guys, that's the symbol rho. And you can just call it rho O for rho object and rho F if you want. Just to save you writing loads of things, this would be HA. So I would rewrite that formula, guys, as HT by 1 minus rho O over rho F. And then we want to get rho O on its own. So same principle guys, just move things away. I won't give you any hints, just see how you go. And again guys, this stuff is difficult. Like, I'm not in any way suggesting it's easy. Loads of students before you struggled. This again would be one of the areas where students struggle the most. So if you do find yourself kind of finding a difficulty, at least you'll know you're in good company. But I hope you recognize that it is a very important skill for a scientist. Okay folks, we'll finish up there. So thank you for your patience. We'll take a look at formula manipulation too, just more complex examples, a different angle really, in lecture 20. So thanks again for your patience guys, and we'll finish her up.